you do if you saw this staring at you, and they're asking you, what can I replace x by? You know you can't replace x by -4, for example. Will not work. I can replace x by 0 at random. I can put a 9 in there at random. Those will work. But there are certain numbers I can't put in there. I like to find my domain. How would you do it? And therefore, I just stand here and guess. What do you think? Why would you do something like I did here to find precise domain? Since this is the square root, guys, should all this, for that large square root, should all this that's underneath there be greater than or equal to 0 for it to make sense? So that large square root makes sense. So let's write this. The inside part must be this in order for that large square root to make sense. Then attempt to solve that. Well, here goes. I'm going to move the 2 over. Multiply or divide by negative. Reverse my symbol. And can someone suggest now to me after I reverse my symbol, what would you do next? Solve for x. Yes? Square both sides. Thank you. And guys, if I square both sides, I'm going to end up with x is less than or equal to, look at this, 4. The truth. Now, so I'm saying this x right here, if this is correct, this x right here must be some number less than or equal to 4. Like, it says equal to, could I put a 4 here, guys? Would that work out? Yeah, 4 would work out. Could I put a 3 in there? Is there a square root for a 3 that exists? If I wanted to use a calculator or whatever, does it at least exist? Could I put a 2 in there for x? I could. Could I put a 1 in there for x? I could. A 0? I could. So this says anything less than 4. -1? No, so there must be more to this. I can't use anything less than or equal to 4. I tried -1. -1 is less than 4, isn't it? I can't let x be -1. So there's something else going on here. Here's what's going on. When you do these composites, you got to pay attention to the domains of the originals. There were some restrictions at the very beginning. I was placing on this one, let me try to find where I am up here. I was placing f of x into g of x. Step back and look at it. Is that true, guys? I was placing f of x into g of x. Was there a restriction on f of x to begin with that I'd better acknowledge right now? Was this a restriction on f of x to begin with? That says, hold on, that's true over there, but, comma, because of that original restriction right here, you also have to consider this. You have to consider both. Now, if you put those two together, that says x is less than or equal to 4, at the same time, though, x must be greater or equal to 0. If you want integral notation, you would say, well, Professor, it means this. You're allowed to use numbers from 0 to 4. Does that make sense? So you got to go back and look at the original restriction there and incorporate that into your answer. By the way, on this last one I just did, guys, if I tried it here, hold on, we got the answer here. This one I was placing what? G into F. Was there a restriction on G in my last problem? What was the restriction on G for the domain? Was that it right there? And did that coincide, or it was the same answer? We looked out here. Didn't have to worry about anything else. They might be the same. This one, though, I had to be careful with. Maybe we'll try one more here. But G, where am I? Oh, right here. Number 1, we got F circle G. Then we did G circle F up here. Now number 3. Let's try this one. I'm going to try F with F. Which means this. All right, a definition. So it says, please go to your f function and put it right back into itself. Guys, the f function is there. If you take it right back into itself, please tell me, does that imply that I'm looking at square root x. Best expressed as fourth root x. And there's your answer. What's my domain on this one? Well, if you look at it right now, you'd say, well, Professor, for a fourth root, that x inside there must be this, or you cannot do a fourth root on it. Now, let's look at the restriction from back here and see if I'm okay. I placed f into f. Was there a restriction on f to begin with? There was. It had to be this. Did this time, did this restriction come out right here for me already? So we're good. That's the final answer. Composites. Now, on the part, when we finally reach calculus, I think I pointed this out before the break. All these composites we work out. But what they're more interested in when you get into that math 7 class, they're going to give you, we'll call it h of x, some function to do a calculus technique on. And I mean, they get crazy on you. It could be this. X plus 2 over x subtract 3 raised to the 19th. Now you know you're not going to spend that thing out 19 times. But they're going to ask you to do some calc technique on it. And to do that calc technique, not in that raw form, that would be crazy. They're going to ask you to please take that h of x and split it up into two functions, f of x and g of x, that when you put the composite of these two functions in the blue, when you put them together, you get the h. In other words, break it up into smaller functions. Can anyone tell me two functions here that you're guaranteed, when you put them together as a composite like this, you'll get the green? Okay, you remember Michael.
F of x equals x to the 19th.
I love it. And
G of x equals x plus 2 over x minus 3.
look at this, guys. He says right there, if you place the g of x with his choice into the x raised to the 19th, you get this. So you've broken this original function, which looks crazy, into two smaller functions. Now these two smaller ones are going to be much easier to deal with, to do that count technique, than this crazy thing here. So that's where it all comes down to for calculus. Guys, any concerns so far? On composites, placing one function into another, watching out for the domain. Now it looks like, I'm going to watch my time here. Oh, yes, hang on. I think we checked. I got time. I got one more of these. Beautiful. To do with your help. We have two more functions. Right side here, guys. Let's call this part 3. And close this down. Part 3, I have given these functions. F of x and g of x, two functions. They're unique. F of x is given as this. 2x plus 1 over x minus 1. The other one in green, g of x is this. X plus 1 over x minus 2. Beautiful. And to close down before the break comes up, I will find composites. We'll just find a couple of these guys. I find, number 1, let's find the composite F circle G of x, which means, I'm trying to find this. I'll come back to it. And number 2, let's turn it around, G with F, which means G of f of x by definition. We're going to find those two composites. This will close us down this part. Okay. Now, before I jump into it, back in the blue, can someone tell me, I'm going to play a part maybe later on. The domain on each one of those given in the blue and the green. Well, the blue one, guys, anyone tell me what would the domain be by mere observation of the blue? X cannot be what? 1. That's the domain. On the green one, by mere observation, the domain here, X cannot be 2. Now let's try to find the composites. Guys, first composite says, please place the G into the F. You're placing the green into the blue. Now, gotta be careful. Placing the green into the blue. That's gonna be matters. Go back to the blue. Try to use my colors here. The blue there's 2 times, and here goes. Place an X, you're gonna put the green. X plus 1 over X minus 2. I'm just patient. And of course, you got plus 1, you're still in the blue here. Over, in place of the X in the blue, you're gonna put the green. X plus 1 over X minus 2 minus 1. Now guys, make sure I'm gonna step to the side here, you guys look at it. Did I do that correctly? Did I place the G into the F correctly? That's the way it looks. Looks crazy. Now you gotta simplify it. Now, can anyone tell me how on earth are you going to simplify this? Someone give me a start. You got to simplify this from algebra the best you can. Any ideas? Anything at all? That's going to be simplified. I think you'll be shocked what it finally comes out to be. But I got to simplify it first. Any ideas? Spring break. If we have one more spring break, guys, we don't have another break, do we? Is there another holiday coming up? I hope not. Roberto, there's not another holiday, is there? I hope not. Gee, we'll be here in the summer. There's a course here. Guys, I would suggest, here we go. I would suggest you try to put these two together with a common denominator. Put these 2 terms together. And down here, same thing, put these 2 terms together with a common denominator. My common denominator definitely is going to be X minus 2. But I might suggest, if I see what that common denominator is going to be, to put those terms together, I would go back to the top and write that 1 as X minus 2 over X minus 2. That's still 1. That's a help. Down here, I'm writing this 1 as X minus 2 over X minus 2, which is still 1. It's really different. So they all match up. And now I do my business here. Back on top, I see distributive property would give me 2x plus 2. That's this, guys. 2x plus 2. I'm adding to it x minus 2 all over a common denominator of x minus 2. Now there's the start of the top. Clean it up. On the bottom part, I see my common denominators put together. I gotta be careful right here. So we end up with x plus 1. I see some sign changes taking place. Negative x plus 2 all over that common denominator. Will you guys agree with that? Everything put together with a common denominator. Now if I simplify it further, let's go into it right here. Beautiful. On top here, combine some like terms. Oh, the 2's cancel. The x's will be 3x. Still over that common denominator. Bottom part. Simplify this, the x's cancel. 1 plus 2 gives me a 3 over that common denominator. That's a little better. Now, can anyone tell me what's going to happen now? What do you think is going to happen? And I'll tell you why. Something nice is going to happen. First of all, let's do this, guys. This means at this point, 3x over x minus 2 is being divided by the bottom part, this. That's what it means. And this. Which means for a division, we are accustomed to doing this. 3x over x minus 2. We'll change it to a multiplication and do a reciprocal, flip this over. That's what we're accustomed to. The true? These will cancel. All the 3's cancel. Are you kidding? Did I make a mistake? Did I make a mistake? So when I clean all this up, are you kidding? Professor, it must be that. It must be X. Hold on. Jeez. I'm getting a little nervous. Did you guys follow what I was doing though? Placing one function into another function and the composite, the answer came out to be X, which is crazy. By the way, if it is X, it looks like it might be X. Let me go back and take a quick check here. Hang on. Domain, X can't be 1, X can't be 2. And I was placing G into F. Guys, it might be, of all the X's down here, should I point out, since I placed which one into which, F into G, G into F. Was there a restriction on G to begin with? X cannot be what? 2. So I should put a comma here and say, oh, you're okay, but you can't let X be 2. Is it true? Woo! Oh. Okay, I see it's almost break time. Now, if all that's true, guys, by the way, let me dive down something here. Johnny, we're saying X cannot be 2. Let me go back to the original question. Suppose I did try to find this. Suppose I tried to find that. What's wrong with 2? That means F of G of 2. And guys, G of 2, if you go back here, would that make a 0 denominator? That's why I can't use X to be a 2. Okay, so X cannot be a 2. Now to finish this up, and we'll take a break here. Now I'd like to find this composite. This one down here, guys. G circle F means now place F into G. Oh boy, placing the blue into the green. Here goes. So let me go down to the green, put in the blue, and it's going to look like this. 2x plus 1 over x minus 1, F into there plus 1, over, I'm squeezing in down here, guys, placing the blue into the green. 2x plus 1, now room down here, guys, over x minus 1, I'll clean that up for you, and then placing the F into the green, minus 2, I think it was. Wow, let me clean that up. So we got 2x plus 1 over x minus 1 plus 1, madness. Bottom part, 2x plus 1 over x minus 1 minus 2. Let me see if that's making sense to me, and I think it is. That's what it looks like right now. Now I need to clean that up. I will suggest a common denominator to clean that up. Guys, there's 1 on the end. I'll not rewrite that 1 on the end as, since I need a common denominator. X minus 1 over x minus 1, that's still 1. This one, I needed x minus 1 on the bottom here, guys. Could I write that as, help me out someone, how can I rewrite the 2 on the end? And have an x minus 1 for a common denominator? Anyone have an idea? How can I rewrite the 2? I would do mine like this then. X minus 1 over x minus 1. That's just being a little clever. Oh guys, that's still 2. Except now everything's over the same denominator. Now to make this work out for us with all that business, let's go to the top, clean this thing up. Here we go. They have the same denominator, no problem, x minus 1. On top, I think the ones will cancel when I combine, oh, you end up with 3x. Bottom part, it's still over x minus 1 down there. That's here, down here, guys. Now, when I clean this up, I gotta be careful here. I gotta clean that up down there. That's 2x plus 1 minus 2x plus 2. Oh, it's 3. I think the 2x is canceled. And you saw what happened earlier. These will cancel, 3's will cancel. What am I going to end up with? X. Again, if I have no mistake. Whew. Did I have a mistake, guys, or is it okay? So I think the composite is X. Is it? I see some looks like professor. Really, this answer is too simple. You got an X over there, you got an X also for this composite. Before I leave it, what was I doing here to find this particular one here, guys? Which go to it right here. I was placing F into G. Was there a restriction on F to begin with? Back here. So sure, I'll take X, but I've got the comma here. You can't let X be 1. G. Both these came out to be an X. Does anyone, before we close down, maybe with some experience before, anyone tell me anything special that may be happening between these two original functions, the blue and the green, if you find the composite, both directions, F circle G, G circle F, do it both ways, and you merely end up with X, and you merely end up with, over here somewhere, I think we end up with X also we did, X and X for both of them. Right here close. Anyone tell me what's happening? That's very seldom. That you form a composite, you get something as simple as X. That's going to lead me into my conversation after the break. Does anyone think they know where we're headed? Yep, that's a key word here. When this happens, these two functions are considered inverse functions. Find the composites, and you get something as simple as X. That's got to work in both directions. F circle G, G circle F. And you get something merely as X when you cleaned up. Those two original functions are said to be inverses of one another. Now, I know it's almost time for a break. Now we'll get into the conversation about inverses. Before we do the break, we'll do something real simple. I mean, real simple. Can someone in class tell me out of an infinite number of ordered pairs, can anyone give me an X and a Y that would satisfy the blue? Replace X by something, but not 1. Replace X by any number you wish. You're going to put a 0 in there, which looks like might be easy. Put a 2 in there, negative 10, 14, 25, and I need 1 ordered pair. Can someone name an ordered pair for me that belongs to this function? An X and a Y.
0, -1.
Okay, 0. Now, Michael, if you say replace X by 0, here and here, you end up with 1 over a -1, which is -1. Now watch what's going to happen. We'll take a break. Michael, class, if I take what he gave me, oh, by the way, before I take it, can someone give me 1 more? Out of an infinite number of possibilities, he gave me 1. Can you give me 1 more before we take a break? Ordered pair belonging to this function besides 0, -1. Replace X by something else. I don't care what you replace X by, just don't replace X by 1. What do you think, guys? You gave me 0, -1, which I like. Give me another one. There are an infinite number of them. And I don't care what you give me. I'm gonna try 4. That's just at random. I'm gonna try 4. If I put X to be a 4 and do my math here, we end up with what? 9 over 3, which is what, 3? Now, Michael, I'm trying to find where we are right here. We're saying these two are inverses of one another. Now, before we close down, take that well-deserved break. I think is a good way to do this. Okay, you gave me 0, -1 belongs to this function. Suppose I interchange those coordinates you gave me. You gave me 0, -1 belongs to the blue. If I interchange them and make it -1, 0, will that one, when I turn it around, you gave me that for the blue, I've turned it around, reverse it, interchange it, for the green. Now, would that interchange satisfy this one? If I replace x by -1, would I get a 0 in the green one? The other one that I came up with was 4, 3, that's the blue one. I came up with that one. Now, if I turn it around and make it 3, 4, I guess I got time where I am here, right here, 3, 4. Will that satisfy the green one? For the 3 in here, you get what, 4 over what? 4 over 1? Will that satisfy? So what's these inverses going to do? They interchange the coordinates from one to the other. The coordinates are being interchanged on these inverses. Guys, we'll do more discussion after the break. Take your well-deserved 10-minute break. I passed out the quizzes for those who were with me earlier. If you didn't get your quiz, I'll be glad to get back to you. Just take your well-deserved 10-minute break.